Hello everyone, my name is Maria Kurant and I am a student at Nicolaus Copernicus University in Toruń, Poland. Today I would like to present the results of my archaeological experiment and research regarding temper of animal and human-related origin in prehistoric ceramics in the light of experimental, traceological and physicochemical studies. The problem of identifying various types of temper of animal origin and related to a human body in prehistoric pottery is of great importance for research on the technology of pottery from this period, including primarily the Neolithic and sub-Neolithic, but also for studies on the spiritual culture and manifestations of ritual behaviors of early Holocene communities, which, as has recently turned out more often, were expressed in temper used in pottery. Studies on organic temper have largely focused on admixtures of plant origin due to the fact that they appear in pottery much more often than those of animal origin, even accidentally as a result of clay contamination. This topic has already been discussed in literature, but the degree of its development should undoubtedly be considered insufficient because so far only basic types of temper, such as bone or shells, have been analyzed in very general terms. Other types of temper, for example meat, blood, hair, nails, wool, antler and feathers, have not been thoroughly studied so far, and their possible use by prehistoric societies has not been verified in any way, both at the level of experimental research and analysis of historic materials. Moreover, the research conducted so far was usually of individual cases, sometimes presented as a curiosity, and was often conducted within a considerable time span, which is why the current knowledge on this field is very dispersed. There is definitely a lack of study that would combine existing and new research, allowing for the creation of some kind of classification, making it possible for interested researchers to identify individual types of temper in question. In order to conduct the experiment, 16 tiles were made from ready-made ceramic mass, 2 for each type of admixture. The temper used were chicken eggshells, snail shells, burnt crushed antler, burnt antler ground in a fine powder, crushed burnt bones, wool, hair, and ground meat. The bone and antler were burnt in a fire pit. Tiles of similar dimensions were prepared, 3 to 4 cm wide and 4.5 cm long. Each sample was given a number from 1 to 8. The drying process lasted 3 days. Then they were fried in a ceramic kiln at 800 degrees Celsius and left to cool until next day. Photography documentation of the tiles was made at each stage. Photographs of the surface were taken before firing, after firing, as well as photographs of the cross sections. The photographs were taken under a microscope at 10, 20 and 40 times magnification. To simulate post-depositional processes, an ultrasonic washer was used. Fragments with a predominantly calcium admixture, eggshell shells, antlers and bone, were left in the washer for half an hour, then dried and the changes documented. Chicken eggshells were crushed with a stone. The ceramic mass created by this kind of temper lost its smoothness, and as a result the tile is rough and the surface is difficult to smooth it. The tile retained its shape in the drying process. After drying, the impurities on the surface of the tile became more visible. Fragments of shells are brittle, falling out of the surface, creating negatives. Clear cracks are visible on the surface. The temper is very visible in the cross-section. The shells have not been completely burnt, they are brittle and fill the entire cracks. They have a rectangular shape and an intense white color. After rinsing in an ultrasonic washer, there are visible negatives left by the eggshell fragments. They have a regular rectangular shape and leave a polygonal slightly curved negatives. The surfaces of the negatives are smooth with a slightly wavy eggshell texture. They also have small cracks. Sometimes shell fragments lying deeper within the ceramic mass are visible, but this is probably the result of the relatively short time the washer was in the operation. The antler was burned in a fire pit, then crushed with a stone mortar. On the surface of the unfired tile, it is black, grey or white, depending on the degree of carbonization. The ceramic mass created as a result of adding this temper was not distinguished by its special plasticity. In the drying process, the plate did not lose its original shape. As a result of firing, the antler turned white and became brittle, as it is distinguishable on the surface. You can see sporadic small cracks. The admixture did not shrink during firing and fills the cracks precisely. The temper is clearly visible in the cross-section, a form of white irregular particles. The cross-section surface is porous and numerous small negatives can be seen. The brittle antler falls out of the surface of the cross-section, leaving irregular depressions. Rinsing in an ultrasonic cleaner revealed irregular negatives of larger pieces of antler. The antler was ground into a fine powder using a stone mortar. The powder gave the ceramic mass unexpected plasticity. The mass was easy to shape and smooth. During the drying process, the plate retains its shape. A small admixture is visible on the surface in the form of dark particles before firing. After firing, the ground antler turned white. The particles are visible on the surface of the plate and are firmly attached to it. There is no shrinkage, the particles are anchored in the mass. Small negatives are visible sporadically. After firing, the tile was more durable than the previous ones and it showed great resistance to crumbling. In the cross-section, the temper is very visible, white in color and evenly distributed. Small irregular negatives can be noticed. The bone was burnt in a fire pit, then crushed into smaller pieces using a stone mortar. Before firing, the temper is easily visible in the ceramic mass in the form of charred irregular lumps. The temper had no effect on the sculpting process. The surface of the tile became rough and it retained its shape during the drying process. After firing, the bone fragments changed their color to white. Numerous cracks and fissures appeared, caused by the crumbling and falling out of the bone particles. In the cross-section, the bone temper has the same characteristics as the crushed antler. It is very difficult to distinguish them. The temper is white in color and the negatives are irregular. To make the temper, wool from Polish sheep was used. Wool added to the ceramic mass made it more durable during the process of forming the tiles. The mass was difficult to form and divide into smaller portions. The wool clung together and was unevenly distributed inside the tile. As a result of uneven distribution, the admixture was visible in the form of single fibers before firing. The tile retained its shape when dried. After firing, the fibers were still preserved in the surface of the plate, but as a result of the temperature, they partially crumbled or split into smaller pieces. They took on a darker brownish color. Negatives of the fibers are also visible. The appearance of the temper in the cross-section is interesting. Fibers are visible, as well as negatives from individual hairs in the form of small tunnels. The clay and temper have taken on various colors from orange to yellow, greenish, and dark blue. The arrangement of fibers is clearly visible, resulting from the kneading of the mass and the formation of the tile. Empty spaces are also visible. This color might be the result of moisture remaining in the wool during firing or cutting off the air supply to the interior of the tile, thereby causing an intentional reduction firing. Due to the uneven distribution of the temper, it is difficult to determine its effect on the strength of the fired tile. Hair in the ceramic mass behaves similarly to wool, but on an even larger scale. The mass was difficult to divide and shape due to its strength. The temper before firing was visible on the surface of the tiles in form of tangled clumps, and the fibers inside were unevenly distributed. The tile did not lose its shape during the drying process. After firing, the hair, similarly to wool, split into smaller fibers and crumbled in places, leaving intricate negatives. It also changed its color to brown. The temper in the cross-section looks similar to the wool temper. A process occurred as a result of which the ceramic mass changed color to yellow and blue-gray. The fiber agglomeration is very visible in the cross-sections, and there are negatives in form of small tunnels. The arrangement of hairs is visible, resulting from the kneading of the ceramic mass and shaping. To make this temper, ground meat was used. The addition of meat made the tile extremely difficult to shape and smooth due to its texture. The admixture was evenly distributed. After the drying process, the tile was deformed and became very brittle, much more so than tiles with other kinds of temper used. The surface of the tile before firing is very porous and irregular. After firing, the tile remained very brittle and irregular. Large pieces fell off its surface. Fragments of the mass mixed with meat can be distinguished due to the irregular negatives. The most interesting thing, however, was the cross-section of the tile. The interior of the tile is filled with multicolored layer, most likely the result of moisture being trapped inside and unplanned reduction firing. The layer is dark blue and green-yellow. Numerous longitudinal depressions can be seen in the layer. Snail shells were crushed with a stone. The ceramic mass, similar to the eggshells, lost its smoothness, but to a lesser extent. The shell pieces were sharp, which made shaping the tile difficult. The delicately opalescent fragments are easily visible on the surface. The tile retained its shape during drying. After firing, the pieces became dull, less sharp and brittle. They crumbled from the surface of the tile. Cracks appeared around the temper. There was a slight shrinkage of the shell fragments, which caused them to easily fall out of the tile, creating variously shaped negatives on the surface. The negatives left by the shells have a distinctly wavy surface, an example of which is shown below. This fragment was washed in an ultrasonic cleaner. The bone temper and the crushed antler temper are indistinguishable from each other at the level of microscopic examination. Further analysis with additional methods is needed to establish the origin of the admixture. It is worth paying attention to the texture of the interior of the negatives left by the shell fragments, because this is the thing that makes it easy to distinguish this kind of temper from, for example, the rather similar egg-shell temper. Negatives left by shells have a clearly wavy surface shown on the photos. The use of different kinds of temper yielded satisfactory results. Despite their similar morphology, temper from eggshells and shells can be easily distinguished by paying attention to the shape and texture of the negatives they left behind. Temper from burned crushed antler and crushed bone are indistinguishable using microscopic analysis. The temper from powdered antler proved to be an ingredient improving the properties of the ceramic mass during the forming process, as well as the properties of the ceramic after firing. The temper from wool and hair yielded mixed results. Analysis of the surface after firing yielded the expected results. However, perhaps this part of the experiment should be repeated, as it was trying to distribute the admixture more evenly in the structure of the tile to avoid trapping moisture inside. The admixture from meat yielded unexpected results. However, due to poor quality of the manufactured tile, it is unlikely that it could have been used by prehistoric communities. When comparing the photos taken and the photos from the source materials, it can be assumed that the temper used produced similar results. The next step will be comparison with archaeological material. My aim is to create a classification of the effects of using the different types of temper. A catalog is illustrated with microphotographs and the results of physicochemical tests such as SEM-ADX and GCMS, to be the source enabling the researchers to search for analogies for the ceramics they are examining. The planned research may also provide completely new data for studies of the sepulchral sphere and ritual behaviors of the prehistoric communities. This knowledge about animal and human temper acquired during experimental research and related to interdisciplinary analysis will be used to study prehistoric ceramics, which will be fragments of vessels from a unique site in Świętoń, Lithuania, where fragments of ceramics containing organic temper in the form of shells and hair have already been found. I also plan to make changes to the experimental plan to make it more credible. For example, use clay specially extracted and prepared using prehistoric techniques, fire it in a fire pit to simulate prehistoric firing process, use wooden molds to standardize the size and shape of the tiles.